Hello everyone, in this video I will present my Physics 102 laboratory experiment on capacitance. The aim of this experiment was to investigate how capacitance depends on plate area and separation distance between two plates, using a parallel plate capacitor setup. According to theory, the capacitance of parallel plate capacitor is given by C equals epsilon times A divided by D. This means that capacitance is directly proportional to the plate area and inversely proportional to the distance between the plates. Now, I will briefly explain the experimental setup. Two conductive plates made of aluminum foil were placed facing each other and connected to the capacitance meter. The plates were mounted on supports so that the distance between them could be adjusted and the overlapping area could be changed. The experiments consist of two parts. In first part, I kept the plate area constant and varied the distance between the plates. For example, at a distance of 5 cm, the average capacitance was about 5.87 picofarad. As we can see, when the distance increases, the capacitance decreases significantly. This behavior clearly supports that the inverse relationship between capacitance and distance. To analyze this more clearly, I plotted capacitance versus inverse distance. The graph showed an approximately linear trend. From the slope of this graph, I calculated the permittivity of free space as approximately 7.9 times 10 to the power of minus 12, which is quite close to the accepted value of 8.85 times 10 to the power of minus 12. In the second part of the experiment, I kept the distance fixed and changed the plate area. For example, at an area of 25 square centimeters, the capacitance was about 0.33 picofarad. And for example, at 1.1 no at 0.01 square meter, it increased about 1 picofarad. This clearly shows that capacitance increases as the plate area increases. Again, when I plotted capacitance versus area, I obtained a linear relationship. From this graph, I estimated the separation distance to be approximately 0.1 meters, which is consistent with the actual setup. Although the results generally match the theory, there were some small deviations. These may be caused by experimental factors such as imperfect alignment of the plates, edge effects, where the electric field is not perfectly uniform, and measurements uncertainties from the capacitance meter. To conclude, this experiment successfully demonstrated that capacitance is inversely proportional to the distance and directly proportional to the plate area. The linear graph and the close arrangement with theoretical values showed that the experiment was reliable and the objective was achieved. Thank you for watching.